Hello and welcome to E233. I'm your instructor, Gregory Myers. In this video, we're going to take a look at our compare by function, which is part of a series of videos focusing on our numerical demo. Now, before you get work with this one, you're going to want to go ahead and watch some of the earlier videos, particularly the one that focuses on how to set up your main and how to set up this project, as well as the left rectangle by function. This compare by function will actually build on the first four methods. And the idea is that we would like to figure out which, or at least have a mechanism by which to figure out which one of these four functions is essentially better at calculating the area for a given example. And so first thing that we want to do is note the function signature here. The function signature is very similar to the earlier examples. And so essentially what it's going to do is it's going to wrap or utilize these other functions. Particularly, it's going to allow for us to choose a particular f, pass it to the compare by function, as well as the xmin, xmax, and n. So we may have a little bit of redundant logic here, and it's just essentially another layer of error checking. So what we're going to do is we're going to simply right click and we're going to navigate, go to the declaration and definition. And what we're going to do is we're going to start off, we're going to go ahead and create a couple of temporary variables, and then we're going to jump into the logic that we need in order to ultimately run our other functions. Once we get that set up, then we're going to focus on the output files and how we actually utilize then these output files to ultimately be able to tell a little more information about the various methods. And if you notice here, we basically, once again, have a hard-coded file. We're going to call it compare.csv. And ultimately, what I want to have in that particular file is simply the method, the function that I've passed, the xmin, xmax, the number of data points that was provided, as well as the area. Now for this particular video, we're going to actually drop the function name, and we'll pick up an explanation of how to do that in a later video. So essentially what you want to do is you want to provide the method, the xmin, the xmax, the n, and then the area. So the first thing that we want to do is we want to somehow capture or recreate, I guess you could say, the results from the right rectangle, left rectangle, mid rectangle, and trapezoidal. And we want to do so with the function that was specified to the compare by function. Now, we also want to, we would not want to unnecessarily call these functions should any of our input arguments essentially violate what those functions need for input arguments. And so to begin with, what we want to do is a similar logic as we had in our earlier examples, and that would be simply that if our f is equal to null, there's pretty much no point in continuing. So in other words, what we want to do is provide a printf that essentially says error, no valid function was provided. And once again, as long as you have some sort of useful information back to the user, the syntax or the verbiage doesn't really matter too much. The next thing that we want to do is we want to verify that, in fact, our xmin is less than our xmax. And so another way of doing that is to check to see if our xmax is less than or equal to our xmin. If that's the case, then we simply want to printf an error message back to the user. So error xmax equal to, and then we're going to include a %f, must be greater than your x min equal to %f. In which case, then you simply want to provide the x max and the x min. The last thing that we want to check here is that our n actually has enough values, or rather requests enough values, to be able to accomplish each one of these calculations. And the minimum number for this particular example, or for these examples, is actually going to be n equals to 2. This changes a little bit with higher order approximations, but for this particular example, we can get by with a minimum of 2. So in other words, if our n is less than 2, we have a problem, in which case we simply want to say printf error n must be greater than or equal to 2. Now, if we have successfully survived all of those questions or conditions, in other words, if we've reached our else, that means then we can proceed with the rest of our process. Most notably, our goal is to ultimately call each one of our functions and then ultimately be able to aggregate those into another file. And so in this case, what we want to do is we want to provide the return value for our area utilizing each one of our functions, and then ultimately store that into a file called compare.csv. Now, please note here, we can either continue with the format as it is and then address the function later, or remove the additional column. Either is fine, but essentially what we want to do is we want to call each one of our functions. And in this case, what we need is we need one additional temporary variable here. We're going to go ahead and call this area. And essentially what it does is it amounts to the return value for each of our calls to our different methods. So in this case, what we want to do is we want to make a call to our left rectangle, and by function, we want to pass to it our f, our x min, our x max, and our n. Likewise, we want to go ahead and make calls to each one of our functions. Our mid, and then lastly, our trapezoidal. This guarantees that our function run, and also that there are output files for each one of our functions or methods. Now, the other thing we want to do is we ultimately want to print the results to a file. So at this point, we also need to have a file pointer. So we'll start off with a output file pointer. And before we call any of our areas, or any of our methods rather, we simply say output is equal to fopen. We can go ahead and hard code the name of the CSV file that we're interested in, and we want to specify that we're opening it for writing. We also want to go ahead and close the file before we forget. And then what we can do after calling each one of our functions, we simply utilize that area variable and we write the output using our output file pointer in the format specified. So in this case, what we want to do is we want to have an fprintf. And for the first one, the method that we're going to be using, yes, we're going to have to hard code this, unfortunately, is going to be left rectangle. And from there, then we can either leave a gap to fill in later for the function, or we can continue on with the %f for the xmin, the %f for the xmax, the %d for the n, and then ultimately a %f for the area followed by a new line. For the first %f, we can specify the xmin, the second will be the xmax, the third will be the n, and then the fourth will simply be the area as it was returned from that function. At this point, we can simply just copy and paste, changing only the method that we have used. So first to right, then to mid for the rectangles, and then ultimately for the trapezoidal rule. At that point, we're done. We can close our output file. We can go ahead and build it. And let's see where we have a mistake real quick. Ah, yes, the perennial mistake where I forget to provide the output file pointer. This, by the way, folks, is probably the most common mistake that I make when I am writing in pretty much any programming language. I have yet to been able to break myself of that habit. All right, and now that we've got this working, you'll notice that I have my numerical demo. I've went ahead and deleted all of the additional files out of it. You'll see there's only numerical demo.exe. And what we'd like to do is we'd like to call this numerical demo.exe with our /p switch. But this time around, what we want to do is we want to call it with compare, and we want to call it by function, and we want to specify one of our built-in functions in our math.h. In this case, it's going to be sine. And we want to specify 0 for the xmin. We're going to specify a value for our xmax, which corresponded to the pi over 2 or 1.57. As we mentioned earlier, that's just an approximation. And we'll go ahead and specify an n for 101. And if we hit enter, you'll notice that there is quite a bit of noise here. In addition to the printf that specified compare by function, there's also the left rectangle by function and so on. So this is just a good way of us knowing that each one of our functions did in fact get called. And now if you type in dir, you'll see that we in fact have several .csv files which indicate that each one of our functions have been called, but also there's a compare.csv. And so if we take a look at that by dragging and dropping and returning, you'll see that we now have a nice summary of what each one of our methods have done. Nice tabular form. Now, the last thing that we want to do is decide exactly what the logical return value for our compare by function. And for this example, we're going to keep this, I guess you could say, kind of simplistic in that I would simply like to return the average area for these four. So what I'm going to do is I'm going to create one more temporary variable. I'm going to call it double area total. And it's going to be kind of an artificial calculation. In other words, at least at this point, it's not going to really have a lot of meaning here. But what we want to do now is we want to say area total is equal to area total plus whatever the area is that's returned for a given method. And so we're going to go ahead and add this to each one of our calls. And then also, before we forget, we want to go ahead and initialize the area total equal to 0, much like the results. Now, we could have also used this results variable, in which case what we would have done is we would have initialized it to 0 and then used it as to tabulate up the values. But I wanted to have this be a little more explicit, and then I want to calculate then our results utilizing our area total and then just divide it by the total number of methods that we have called. In this case, we have a total of 4 methods. Once again, if you could argue that this particular value doesn't have a tremendous amount of meaning other than just getting an average of our results here. We can improve on this later on. But now when you call your numerical demo using your /p compare by function, and for this particular function, you'll at least see that our average value appears to be somewhere around what we would expect our value to be. In other words, if you've done the calculations by hand, you know that you're supposed to get 1, and this appears to be roughly in the right area. So hopefully, once again, you found this video useful. As always, if you've got any questions or comments, don't hesitate to email me. And thank you for watching.